Howdy guys, we would like to share our project regarding to identifying and understanding SS tweets using random voice and topic moduling methods. In recent years, SS becomes the most active terrorist organization in the world. When people talking about why SS could grow so fast, social media becomes one of the reasons. Take Twitter as an example. There are lots of SS active followers sharing terrorism posts. SS not only forward these messages, but also directly interact with supporters. In the November 2015, there were a series of Islam's terrorist attack happened. After that, SS made the statement online to declare the responsibility, which leads over 900 SS Twitter accounts has been hacked. There are several academic studies regarding the analysis of the user network, sentiment analysis, and the characteristics of the SS Twitter users. In this case, our project mainly focusing on the content analysis of this tweet. The dataset we used for our project is a file provided by Fifth Trip. It includes over 17,000 tweets from about 100 SS fanboys from all over the world since the November 2015 Paris attacks. After a simple investigation, we used the username and their post to make a histogram of the post distribution. According to the graph, it shows there is a great portion of active SS fanboys.
Okay, we are now talking about the classification task on this dataset. We first analyzed ISI's tweets dataset and another normal English words dataset. We found that ISI's tweets has many ISI-specific words, and they have different topic words. For example, in this word cloud, the normal tweets has some common used words as their topic words, while ISS tweets has some strange words as their most frequent words, such as killed, Syria, and ISI. So inspired by the difference of word frequency, we built a classification model based on the word frequency. In detail, we first use TF-IDF to embed each tweet into a feature vector, and we then use random forest to map the feature vector to prediction label. And this is our classification result. Table 1 shows that with feature size increasing, the accuracy also increased. And table 2 shows that classifying ISI tweets is a bit harder than classifying normal tweets because the test score in ISI's subset is a bit lower. This may due to the extremists would make their tweets normal, so to avoid being censored. And we also compute the feature importance for each term and find out the most important features are the words that most frequently appears in extremists tweets, which also are their topic words such as RT, HTTPS, serious, ISS, and kills, such strange words. And we also check some failure cases. False negative result may because they didn't use ISI's specific words, but use a lot of common words which have low TF-IDF score, such as the first two example of false negative cases. And thus the classifier doesn't have enough specific feature to categorize them as positive. And false positive one is on the contrary.
So we also trained a target model, basically the LDA model for like all the tweets we have. So the settings for our LDA model is that we use the max DF as a 0.8, and we use the min DF to be a 0.001, and we set the topic number to be 5. So the LDA model takes the set of the tweets as the input and output the keywords for like the 5 topics we set, and also the labels for every tweet in that set of tweets. So here are the top 10 keywords for like all the 5 topics we have. So for topic 0, we can see the keywords such as fat and the bag. So the topic 0 is very relevant to the revenge. For topic 1, we see the keywords such as army and soldier and force. So we know that topic 1 is relevant to the military. For topic 2, we see the words such as state, see, want, and think. So this is relevant to the personal thoughts. So for topic 3, it's mainly relevant to the 2 places and also 1 person. So for topic 4, we can see we have the code for the come and also HTTPS. So the topic 4 is very relevant to sharing a link or say a retweet from someone else. So based on our trained LDA model, we want to further answer the following 3 questions. So the first question is, what is the topic distribution among all the tweets? So we basically are getting the labels for like every tweet we have, and then we count their numbers. So we can see that the topic 4 has the largest number of tweets, has a 4,600, and it's mainly about sharing a link or the retweets. And question 2, what is the topic distribution differences between all the users? So first, we calculated the standard deviation for the percentage of every topic for like all the users. And we found that the topic 1 has, say, a much larger standard deviation value than the other topics. And we can see the topic 1 here is relevant to the military. So this means that there are some users, they just post a lot of tweets on the topic 1 than the other users. And maybe we may want to take some actions on such users, such as keep monitoring their posts. The last question is that we are trying to find the best LDA score. So we basically we chose the 2 commonly used scores. It's a perplexity and the coherence. And we also train the different LDA models, and we are manually check their keywords so that we can know the quality of these models. And then we just compare the scores for the trained models with the quantities from our judgments. So in our project, we trained a random forest model to identify the SS tweets and the non-SS tweets. And we also trained a topic model to identify the topics discussed in the tweets from SS. And in the future, we plan to test our model on some other relevant tweets. And we may also want to find a better score for the LDA. Thank you very much.